Okay, I think we are good. Cool. So the first attempt at a stream on Twitch, at least a technical stream. Does this all work? Is chat available? Chat is available. My stream actually works. Let me have a look again, like this. Checking it on my tablet right now. Yeah, I can see this running. Just cool, awesome. I guess we are good to go. Again, this is a first stream ever. I don't really expect a lot of people to join in, but it's a great way to start testing out streaming. Okay, so what I'm gonna be talking about today, or what I'm gonna try to stream. Actually, I'm gonna wait a couple of minutes. I told people at 4 and it's 15:57. So just checking the little things here, tidbits. I think this is. Let me see. Does this text look big enough? I can always increase it a bit like that. Yeah, that should be okay. Cool. It's a bit better. Still need to work out the kinks of how good this looks. So stream is currently going through my laptop to my desktop PC through a capture card. At least the internet should be good. It's at 50 megabits upload, so fingers crossed. Vodafone. I hope the sound is okay. I really don't. I think I heard myself for a second, but I'm not sure. If anybody joins, and then you can let me know if the sound is good. Give it a few seconds more. I guess this works now, right? It's 4 o'clock. I guess I can get started. I see the chat works. Managed to, well, send a message. My stream does work. I can see it showing up on some other devices I have around me. Yeah, let's go. So, welcome to this attempted stream or first stream I try to run on Twitch. And this stream is, it's a test stream. So the first thing I'm going to talk about is testing, right? So let's test the stream with a testing topic. And the testing topic is going to be around CDK, which is Cloud Development Kit. I'll get a bit into that in a moment or so. First of all, who am I? My name is Darko Mesaros. I am a developer advocate, senior developer advocate at AWS. I work covering the Central and Eastern European regions along with Russia. And my strengths, my focuses are within development tools, infrastructure as code, management tools, and all those kind of things. I've been working for AWS for the last 4 years now, a bit more. Started in premium support, moved from premium support to solution architecture, and now, it's my job to talk to you, developers and engineers, and potentially teach you something, allow you to teach me something so I can funnel that information back to service teams and help, our products grow and help you have a better experience overall. Now, so that's enough about me. This is a stream, so there will be no slides, there will be no presentations. It's gonna be me just dabbling around with some code. It's not very scripted. I have just a few points I want to get through, but most of the time we're gonna be looking at this piece of code and maybe my browser, right? So okay, let's start. So what is infrastructure as code? So when we talk about infrastructure as code, this is not going to be a full-on intro to it, but infrastructure as code is a way to describe, your infrastructure as a piece of code. In this modern cloud-based world, we like to take, because everything is as a service, everything is an API call right now. What we can do with the cloud, with the modern dynamics of things is take our infrastructure, define it in a text file and a template, be that, YAML, JSON, specific domain, specific language, or whatever you would like, and have that piece of code, have that template actually provision our infrastructure, right? Usually when people talk about infrastructure as code on AWS, they talk about CloudFormation, which is a very commonly used piece of infrastructure as code. And it's great, right? But we have actually made something else, which is called CDK, which kind of builds on top of CloudFormation. And there's slight differences between the two of these. So I will not get into them, but today will be our main focus on CDK. Now, why would you use infrastructure as code? If there was an audience, I would ask, does anybody use infrastructure as code? And if you're not, why not? You should be. So with the advent of ISE, we have the ability now to basically provision resources and treat our infrastructure, treat our virtual machines, our databases, everything we do in AWS, treat it as an application. That means we can take the same best practices from building applications to actually building infrastructure. So from the concept of putting stuff in source repositories and Git, right? Versioning, testing, deploying through a pipeline. So there's no longer a case where you would, have to call a guy to deploy things, but you would actually just make a Git push. And that Git push would go through all the testing pipelines required. It would be, vetted, be secure, it will be versionable, which means rollback is quite easy, right? So, and one of the aspects of those benefits of infrastructure as code we're going to be talking about today is testing. So, important part with any application development is testing. Testing basically gives us the benefit of not breaking our application when we push to production. You make a change, you want to make sure that change actually doesn't break things. So, like in testing application, when we talk about unit tests and integration tests, we have similar aspects to it in infrastructure as code, right, or IAC. So, what is CDK, right? Let me move on. We talked about ISE, we talked about why ISE, we talked about testing about it. So what is CDK? Well, CDK simply put is a piece of software, right? It's a framework that allows you to deploy infrastructure in the means of code, but it is actually leveraging different languages. So CloudFormation, which is a traditional IAC language we have, or a traditional product or service we have, uses YAML or JSON. So it's a templating engine where you kind of make templates and you just write down what you want to be provisioned, and you get that. With CDK, you describe your application's infrastructure using a general purpose programming language, right? So far, the languages we have supported are TypeScript, JavaScript, Python, .NET, and Java, I believe. I think that's it for now. But again, it's an open source product. We can actually have a look at it. If we have a GitHub AWS CDK, it's an open source product where you can actually, make pull requests. Yeah, you can add things. So currently, yes, JavaScript and TypeScript, Python, Java, and .NET are currently supported. Again, it gives you the ability, so if you're brave enough, if you're adventurous enough, you can also introduce the language of your choice to CDK with a proper pull request. And I always advise people, if you have good ideas, if you want to contribute to this, go to the CDK GitHub page and feel free to add things to it. So yeah, it's built on top of CloudFormation. So basically, using programming constructs of general purpose programming languages, you can generate CloudFormation, right? So it does not perform changes to AWS directly, but it actually uses CloudFormation instead. So it doesn't make a bunch of API calls. It generates CloudFormation templates, then that CloudFormation template is applied to your AWS account, which in turn provisions all the resources. Actually, a sip of coffee. Actually, let me just try something out. I have back there. Let's deploy a sample application, right? So create a directory where we're gonna work it. It's an empty directory. We do the command CDK init. Give it sample app language equals TypeScript. Now, what we told here is, hey, CDK, initialize this directory as an application, use the sample app format, and use the language TypeScript. So it will generate all the things we need for a language-driven, TypeScript-driven CDK application. So it's going to run all the things, npm install, it's going to create the scaffolding that we need. Basically, right out of the box after this is done, we can just kick it off, right? So let's give it a moment. Awesome. So if we look here, we have a couple of, a bunch of files. We have package.json, we have some tests, we have CDK JSON, we have a README file, binary files, and library files, right? So the first thing you would like to go to is in lib, and then the testing sample stack TS. So actually it takes the directory name as the application of the name of the stack and the application. So this is the stack we are creating, right? So here's actually where you define what are you going to create. So it imports a whole bunch of libraries for CDK where we actually which we use for creating resources, and it exports this stack called testing sample stack. And in this case, what it will create an SQS queue and then SNS topic, and it will subscribe the SNS queue to the SQS topic. Cool. So what we need to do right now is, if I do just npm run build, which I will tell npm in this case to run the TypeScript build command. So this will generate JavaScript files. Varun, okay, it runs the TSC. And if I do CDK synth, now the CDK synth command will actually synthesize CloudFormation templates. As I mentioned, it's built on top of CloudFormation. So what it will do here, it will synthesize CloudFormation templates. So if I do this, it will just spit out the CloudFormation template here. And if I would like to read it, you will see that it's actually creates, the SQSQ, you can see here, it creates the queue policy, it creates, SNS topic, whole bunch of things, right? So it does this all for us. Now, if I want to deploy, well, CDK deploy. If I run yes, it basically tells me here it's gonna make some IAM statement changes because that's important that we know what kind of changes will happen to our IAM policies, just so we can be sure. If I do this, now, if the demo gods work, this should actually deploy things to CloudFormation. Awesome. Coolio. While I have a look at that, let's have a look at CloudFormation, because I told you that this, at the end of the day, will be part of CloudFormation. So going here, opening up the CloudFormation console. Aha, I'm in the wrong region. This should be all deploying to the Ireland region, EU West 1. And if you can see here, let me actually zoom in a bit. Testing sample stack. This is the stack that was just created, right? And the resources you can see here is an SNS topic, a subscription, a queue policy, and a queue, and some CDK metadata. That's it, right? So this stack is currently created. Simple as that. So it took me, a couple of lines of code or a couple of commands to run all this. So look at this, from making a directory, entering the directory, initializing it, and just running npm run build and CDK deploy would actually deploy this application. Awesome. Now, let's move along a bit. So that's CDK for you, right? Super simple, very easy to make changes to it, very easy to get started with. Once you get deeper into it, it can get a bit more complex, but with complexity, you gain more power, right? So, but what also do you get with complexity? Yeah, you get problems, you get issues, right? So imagine if my testing sample here, or my testing application, was a pretty complex application, and I have some rules that I may want to have certain policies on that SQSQ, right? Like a retention policy, and I want to make sure that I always apply that no matter what, because if I break it, I might break production, who knows what. So this is where testing comes in. So the same way you would approach testing on software deployment or software development, you can do the same here, right? So when building an application, you want to spend some time on building tests. First of all, you need to determine what you want to test, and secondly, you want to actually develop those tests. It's called test-driven development, where you write a test first, and then actually work on building the piece of code. In this case, we can kind of approach it the same way. And again, all of this, all the testing, all the amazing stuff you see here can be, funneled to a pipeline, and that pipeline can actually be, taking one of your Git commits from your laptop to a production system in just a matter of minutes, with proper pipelines and proper stages in place. And also it will test the code as long as, well, you have it all set up, and you should be pretty secure once you do that. So what kind of tests do we have when it comes to CDK? There's 3 types of tests we can do on CDK. First, we will be using something called Jest, which is a tool or a framework, or a JavaScript testing framework that works with CDK. So we will be using Jest in these cases, and for some things as well not. But there's 3 types of tests you can do, or three types of testing you can also achieve in this case. One thing is snapshot tests, right? Snapshot test is this kind of where you create this ideal scenario. Like you make a snapshot of the system, of the deployment. This is how you wish it to look, and anything that deviates from this is actually a problem, right? So it generates these snapshots, and then any further testing that deviates from this snapshot will be marked as failed. It's a super simple way to approach it, but again, it has some limitations. You potentially will not like to do that all the time. Now, the second approach would be fine-grained assertions, and this is where more traditional testing comes into play. This is where you would basically assert some things, define some things that must exist in a specific way. Let's say your retention policy for SQSQ must be 14 days, right? And instead of making a snapshot of the 14-day valued CDK application, you will take a test, right? That if this thing deploys dead letter queue, for example, it will have a retention policy of 14 days. And at the end of the day, because we're using general purpose programming languages, using something like validation tests could be very useful. Basically just additional validation to a piece of code saying, hey, you know what, if this amount of, if this parameter is not this value, your tests are failing. But actually, let's do something. Let's build on top of those snapshots. On those, let's start with snapshot tests, right? So in this case, let's do I have here? Okay, let's create. Let's create a new application that we're gonna be. Actually, let's create a library, right? So CDK. Instead of creating a full application that has a stack, let's just create a library that we're gonna test against, right? Init. I'm gonna be using TypeScript in this case, and we're gonna create a library. So again, like in the sample before, it creates the scaffolding, everything we need to run our application successfully. Okay. So we have created an application, and if we see here, we have no binary files, but if you go to lib, we have index.ts. Now we're gonna ignore index.ts and create our own file that's gonna actually create a dead letter queue, and we're gonna be running test against it. So if we create a file called lib, and then name it ts. And I have a piece of code that I can copy and paste because nobody wants to see me, typing a bunch of code. Cool. So if you can see here, this piece of CloudFormation CDK code creates a dead letter queue, right? With a bunch of things, like creates a CloudWatch alarm. Simple as that, right? So it doesn't create a stack. It creates it extends the SQS dead queue, SQSQ class by creating a dead letter queue in this case. Now, one thing we need to do before I continue on this is we need to install a bunch of npm requirements. So npm install CDK AWS SQS. So we need these two libraries installed as we will be using them in creation of this dead letter queue. Did I type it correctly? Yes, I did. Okay. Cool. Come on. Awesome. Now, I mentioned we need some testing frameworks, right? Again, let's install Jest, and let's install the Assertion framework for CDK. This is a library coming from AWS CDK. Again, a bunch of npm install save dev Jest at AWS types. Awesome. So this should install the required libraries for testing. Awesome. Now we have all these things. We have our CDK. If I would run npm run build, it should be successful. Yes. Okay. We have no errors. So technically now, if I would run a CDK, it would be able to use CDK applications would be able to use this library in creating dead letter queues. Now let's write a test for this dead letter queue. Now before I continue, I need to add something to the package.json, which is present in the root of this directory. So I need to add a thing called just another part of this JSON called jest. Now this I don't have typed out, but module. Cool. Now we have added this. This should be fine if I do npm run build again. Hopefully I didn't break anything. Good. Cool. Now I have added all the things I need to do my testing. Now let's actually write that test. And where does the test sit? Well, in the test directory. So if we see the tests directory here, we can see that we have some CDK testing, and these testings are these testing files are created for well, the default index.ts file that comes with this library creation scaffold. So to create a test, what we're going to do is run tests, edit a file called dead letter queue test.ts, right? Set paste, because I want to paste things again. And if you can see here, it will do something similar in this case. So it will, again, we import a bunch of things. We import the synth utilities for the CDK assert, right? We're going to use it assert in this case to actually run the tests. We're importing the dead letter queue library, and then actually creating this test, which creates a new stack. And basically with this new dead letter queue, the stack that is created, it expects it to match a snapshot. Right? But where's our snapshot? What we need to do is we need to run the test first, and then we'll have a snapshot. So npm run build. Okay, now npm run build has succeeded. Npm test, and this should run jest in this case for some testing. Awesome. So it has actually finished the test. So the test is successful. Basically, what it has done for this test called dead letter queue, it has created a snapshot, right? So it has created a snapshot that's going to be used in the future. And if we look at the directory called, if we go to cd tests, there's a directory called snapshots, and there's a snapshot of this dead letter queue. So if I would open it, you will see what it expects from this snapshot, right? So again, creates basically SQS queue with an alarm description, all those things, and CloudWatch alarm. So it basically expects something like this will be created. And this, well, right now this hasn't tested anything. So what we need to do here is actually, make some tests. So let's make some changes to our library, to our dead letter queue file. and see how can we break this. By adding something here, for example, let's add a period. Called duration. Okay, so we have made this change. npm run build. Let's see if this is successful, if I haven't busted up something. Okay, all good. Npm test. Hopefully this should fail. Awesome. It says snapshot failed. Why is that? So if we have a look at this output here, now it basically says what it has received and what it has in a snapshot. So it actually, the test called ELQ creates an alarm, is expected to match a snapshot. Within the snapshot, our period is actually set to 300 seconds or 5 minutes, as that is the default value, and it was assumed by the snapshot in itself. Once we have changed that value from 300 seconds to 1 minute, well, the test no longer the current status no longer matches the snapshot, thus the test has failed, right? So this is a very simple, quick way to kind of make a test that will, well, break if we make any changes that go through the snapshot. Now, one of the things what we can do now is either make a change to our code, right? Actually go in, change that period back to 5 minutes, or actually remove it altogether. Or I can accept these changes, because if you see here, it says inspect your code changes to run npm test -UUU. It will actually update the snapshot. So if I do npm test this will update the snapshot. See if one is updated. And if I would be running npm test again, this should pass. There you go. Awesome. Now, see, this was pretty simple. Again, it's robust, it's quick, it's easy to get into, but again, it does not have a lot of flexibility as some later things we're going to be doing. So let's look at our dead letter queue once again. So going back to our dead letter queue file, let's add something to it. Let's add some properties to this dead letter queue. Make this nice. So retention, I mentioned some retention period, let's add it. I hope this is the correct syntax. I'm actually not copy pasting this, but I'm reading it off a different screen. Not that. Okay, does this not work? I added a keyboard. It works. Okay, cool. npm build. No, sorry. npm run build. Okay, I've added something to that dead letter queue. Let's see if this actually breaks it. npm test. Yep, it has failed. So the snapshot has again failed, even though I have not actually changed that specific CloudWatch alarm. I have made changes to the top object, to the SQSQ in this case. And again, it will expect that the snapshot matches the current, or actually it expects that my current template or my current library matches the snapshot in its place. So how do we fix this? Right, the same thing as before. Again, we can either match the snapshot in this case, or say, you know what, this is something I want, and let me do this. But by this way, I'm keeping those snapshots, and also make sure to ship these snapshots together with your code to a good repository, because by shipping them, you can use them in your pipeline testing. If the snapshot is not present, npm test will always pass, because it will assume that you don't have a valid a snapshot in place, and it will create a new one no matter what you have. So it's very important that you have those snapshots together with your piece of code moving through a pipeline. So you've seen the snapshots here, right? You've seen that this, how we can relatively simply make some testing against CDK. Instead of, just doing, writing specific tests, we can make a snapshot based on something we expect is good, and then use that snapshot in our further testing to potentially prevent some changes to our library or our stack or whatnot, right? But now let's talk about something else, right? Snapshots are super convenient to write, and it's mostly here to kind of detect some potential accidental change, right? But when we want to test some things that are specific, right? Something like a unit test. I expect a certain parameter, a certain property of a resource to be something. This is where I would write fine-grained assertions on given resources, right? So this is where I would say, you know what, hey, I expect that my retention period is 14 days. I have not created a snapshot of it, but I've done it initially, that this is how my piece of code should look. Right? Let's see that in action, right? So let's again let's look at our alarm, our piece of code here. So if we go here to lib and edit the letter Q file, we can see here that we have a couple of things, right? We have a where is it? Dimension. We have a description. We have a period evaluation. Have the period, duration of the period, and the threshold, right? Now let's make some changes to the test we have. So I would like, instead of using a snapshot, I want to actually expect a specific alarm to exist with my SQS queue, right? Instead of running it from a snapshot. So let's write a test that will expect a CloudWatch alarm to exist on my SQS queue. So go back, cd test, vim, the letter Q, ts. Let's make some changes here, right? So I have, again, a piece of code here that I'm gonna be importing. Cool. I think this is it, yeah. So awesome. I just need one more thing. I need to add jest to this. So let's add jest. So again, one import AWS CDK assert jest. So again, like before, we're importing our library that we created, and the test here is that the dead letter Q actually creates an alarm. It creates a CloudWatch alarm that's going to be used. So again, creates a new stack, creates a new dead letter Q, and what it actually expects, in this case, if you look here, it expects that this piece of on line 12, it expects that this stack has a resource, AWS CloudWatch alarm, with these settings, right? The metric name should be approximate number of messages visible. This should be the namespace, and these should be the dimensions, actually getting the attribute from the queue name, etc., etc. So this test actually expects something to be existing in this case. So again, if I go here and actually, So if I do this, it will actually, npm should, I think, just should warn me about having an existing snapshot. If npm run build. While that is doing, let me have a look here. Okay, that's fine. npm run test. Okay, cool. So it says a snapshot is obsolete, right? So it, basically what happens now is I no longer have a need for a snapshot because I have no test defined in my testing files that expects a snapshot to match. So if I just run npm test -- u, this will again just go through it all, and npm test should be fine right now. There you go. Let's add another test. Let's vim test dead letter q. Oh, I'm here already. Dead letter q test ts. Let's add something more to the bottom of. Where is this? So here, let's make this look nicer. Gotta remember those vim commands. So in this case, what we have is we have a test that expects the dead letter Q retention period, right? So again, like the same before, it creates a stack. It creates a new dead letter Q from that library. It expects the stack that the stack has an SQS parameter of message retention period set to this much seconds, which equates to 14 days. Now, if I would save this, npm run build, npm run test, it has failed. Something has failed. Tests cannot be nested. Okay. I have it's the good old typo. This should work now, right? Yeah. Let's not nest our tests. Make this look nice. npm run build. Cool. npm run tests. The beauty of streams is you can act like you know stuff, and then you fail like, oh, it's just a stream. Of course, it's this should be very easygoing. So as you see, typos exist. Okay, now the test is passed because if we remember, if we go back, no, back, CDK. If we go back and to our lib file and that letter q.ts, we can see here that that retention period is actually set to 14 days, right? Pretty cool indeed. Now, there's another way to do this, right? This is a simple way. So what we have done here is, instead of making snapshots, we have actually described what pieces of what parameters and how do we want them to be set up on specific resources within the CDK stack. So from having a call watch alarm existing in that stack to having a dead letter queue, a queue with a specific setting existing in that stack. If our CDK stack, once it's created or once it's tested, does not create these stacks, it will actually be considered a failed test. So again, pretty neat way that we can define some things. Again, test-driven development, write your tests here, then write your CDK code to match this. And that way you will always be sure that you have a proper test written, right? Again, there's a whole testing theory and testing philosophy behind it. What is your return on investment when we talk about testing? What, when you compare the time invested into writing tests to the code coverage, right? Again, you have to find that golden ratio or golden middle where it will be not too much time spent, but also have enough code coverage inside of your test. The same goes here for CDK. Make sure to test the things that are critical. Make sure to write the proper test, to invest enough time, not too much, not too little time in writing CDK tests. Now, something not related to CDK or the testing framework in itself is something called, well, it's basically validating constructs, right? So instead of having such a testing framework built in directly, you can also do some things like construct validation. So when doing properties, right, you can create a property interface for your libraries. When doing properties, or when creating these alarms, when creating these resources, you can throw alarms or throw errors if they do not match on things. So you can straight within your CDK code define what kind of stuff would you like to test against. In a sense, for example, when creating my dead letter queue, I can make basically an if-then statement that will verify that my retention days is 14 days or less, or 14 days or more. Otherwise, it will throw an error, blah, 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 right? So those kind of things must exist. So let me actually, can I give you an example on that? I actually have an application here that I have created myself. I believe I have something like that here. If I go to lib and then, no, I have not created that here. Let's see, how can we do this in the fastest way possible? So testing example. One of the things we can do here is if we go to lib and then dead letter Q, TS, we can actually create a property, right? When I said a property or a props interface, this is basically a simple way to pass properties onto your CDK libraries, right? So for example, let's do some typing, right? Export interface. Let's create some properties. Retention. Let's make an optional property, retention, and then just take a number, right? So we have created a dead letter Q properties props interface, and we're going to be using this thing within our SQSQ, right? During the constructor, we are going to be adding some properties, right? So after the ID, let's do this. Props. So we're taking the properties interface we have created up before. Cool. Now, before kicking it off, this is where you would write your if statements, right? So if I do if props no. So in this case, if we have retention days set to something and it's more than 14 days, the thing we're going to be doing here is we're going to be throwing out an error, right? throw new error red. Cool, right? That's it. Simple as that. So now when we do it here, now when we want to invoke this, what we can do is just add the property called props retention days. Sorry, that's not how it works. It will take either this property or the number 14, right? So this is how we invoke our class, right? With this property, duration days, props, retention days. I hope that looks all good. Otherwise, did I do this correctly? Yeah. Okay, cool. Now, what I've done here right now is created a property interface. The property interface basically takes any type of property or value, in this case, a number for our retention days. And when the actual dead letter queue as a resource is being created, it will take that property. And if that property is defined, but is more than 14, it will throw an error. Retention days may not exceed 14 days. And the way we pick up this property is by using this, where we say the retention period period property of the resource should be either the value of the property in the props interface or the number 14. How do we actually now work with this? Let's create a stack, right? So what we need to do, we need to create something in this case. Oh, that's a long file I would need to add. Let's see how would be the best way to do this. Actually, we can just use a test. We can create a test because a test creates a stack. So I keep banging on my mic. Let's go to tests and edit our dead letter Q tests, right? So add more tests. Test number 1, test called, actually, let's remove all these tests from here. Cool, awesome. So test, first of all, we need to test if the retention period can be configured, right? Good. Close it all down. So let's create a stack, right? Const stack, x new stack. Let's create the dead letter Q from dead letter Q, right? Stack. Let's name it DLQ, and let's add some things to it. Gonna make sure to close those brackets properly. Let's set the property retention days 7. So what this will do, it will actually expect. We need to have it expect stack to have resource. I wish I had this in a text file so I can copy paste it, but okay. Expect to have a text to have a resource SQSQ with a property called message retention period, something like this, right? By the way, I don't have this in my head. I actually have a little place I'm reading from, but it's not very simple for me to copy paste it from there. Time to close this off by this and then this. Awesome. So this test now expects that a period can be configured, right? So it expects that we can do this, and this can be actually configured with this, right? So we pass it a variable, a property called retention day 7, and if it picks up, it actually expects that the resource will have a retention period of 7 days. Now, other tests we can do here is, let's actually copy a bunch of these things so we don't have to. I'll create a new dead letter queue, like that. Those things I can delete. So again, we create a new test where we actually expect configure so where we actually test that the configurable retention cannot exceed 14 days. So now let's make an expect actually. Boy, if this works out of the box, I'm gonna be surprised. New dead letter queue, queue stack, call it stack, call it DLQ. Again, close it off. Not that. Let's give it a bad test. 15. To grow. So in this case, we are expecting that we will be receiving an error called the retention days may not exceed. So in this case, we are just testing, have we actually inserted that proper validation where we actually test the validation. So we're passing it a bad value that we should actually expect to have an error. Now, one of the things I need to confirm is, let me have a look for split lib. What is the error I have added there? Retention days may not exceed 14 days. It's okay. Okay. Cool. Now, once we have done this, now let's see if this will work. And run build. Exclude typo. Expect, yes, of course. Okay, let's see if this works now. Tests have passed. So we have actually, we have all the tests we have configured, in this case, have passed. So we have tested, will it accept a value? It does accept a value. So going back. So we have tested, can the retention period be configured? It can, right? We also have tested, if we actually give it a bad value, will it throw an error? It will, right? So in this case, we're testing the test. So I must say that this overall was successful. Now, this stack in itself, this library, what it does, it is, as you can see, it creates a SQS queue with a dead letter queue and a CloudWatch alarm. Nothing special, right? So it's It's pretty simple. It's super fast for me to show, but actually, I've built something a bit more different in my own spare time. If I go here, this is a library. Where are you? EC2 instance, DS. So now this library, actually what it does, it creates an EC2 instance, it creates a VPC. Actually, yeah, it creates a VPC. Well, this library actually just creates an EC2 instance, but what I've written here is, just a simple way, hey, create my new EC2 instance. It's a T3 instance, T3 micro. It uses the Amazon Linux image, and it also takes a property of VPC when it's being launched. Now, when you look at the application here, we're launching this application like so. If we go to lib, and then where is it? Yes, the stack. If you look at the stack, what it does here, it imports the EC2 instance, the library I've created before. It creates a VPC here, just a toggle plain VPC, and it creates my EC2 instance with that VPC as a parameter. So it's smart enough to create the VPC with all the things it needs, and then after that, it will create the EC2 instance within that VPC. Which is all fine and dandy, and that should work, but npm run build. This should all work, I think. Yeah, and if I go here, yeah, that's fine. If I would do npm run or npm test, as you can see, it has failed. Why has it failed? So the reason of the failure here, as we can see, it expects to have resources. So in this case, we have used fine-grained assertions to actually test, is this instance type an M5 large? And if you've been paying attention, my instance is a T3 micro. This is how I've been setting it up in my CDK code. So again, if I would be, go back. If I would go lib change this to something else. EC2 instance type. What did we say? M5. Large. npm run build again. npm test. And this should be fine, right? Again, what it has done right now, it has the EC2 instance is M5. As we can see, the test has passed. Let's have a look at the test. How does that look? So pretty simple. Again, this is a test. It creates a new instance with a new VPC, and it expects that instance type is M5 large. What actually it does, the test here, it actually, we pass it on like, hey, create a new VPC, because this instance as a parameter doesn't just take a value, it takes a whole VPC, and it makes sure that it's done doing it that way. Pretty simple. Let's just see if this will deploy. I think it may not, because this one is, I think it will deploy to Ireland. I'm not sure how I set it up, but it actually might fail because I think I am at the limit of my VPCs in that region. Oh, it's already 5 o'clock. This stream has passed quite fast. So I'll just check to see if this will fail and how it will fail, and then we can wrap it up. So it's creating a CloudFormation change set. and this is something we can see here happening. Yes, see it. We can see that the CloudFormation change set is actually happening. So it's triggering the stack creation. Now, what kind of events do we have so far? It's awesome. So it has started creating VPCs. It creates CDK metadata. And we see roughly the same output in text form here, right? It has created an instance role. VPC subnet. There you go. It actually works. I may have increased my VPC limit count. So again, this takes a bit longer time to create because it's an EC2 instance, so it waits for it to spin up and all that stuff. It creates a whole brand new VPC. But again, you've seen two examples of running fine-grained assertions. One from an SQS queue where we have expected, a specific configuration, and the second one on an EC2 instance where we again expected a specific configuration of an EC2 instance, such as instance size. Okay. To wrap all this up, well, this is being created. I mean, it doesn't really matter. To wrap all this up, I just want to point you to one location. I think I have it somewhere. Testing. Okay, cool. Because everything I talked about today is actually was built upon from a blog post delivered by my colleague, written by my colleague Rico Hubers. He wrote basically everything I've done today here is present here. The entire explanation of the tests. The code is here as well that I used, which I kind of badly retyped and copy pasted. But the entire stream was actually based on this. And I suggest if you want more information, want to read up on a bit more on this, please do so at this blog post. And if feedback is always welcome for myself or for my colleague Rico as well. Well, this is pretty cool. I'm very happy how this stream turned out. I believe there will be a recording of it. I think Twitch saves it automatically. Let me know what you think. Let me know what we can improve, what kind of topic would you like to hear furthermore. I plan to do this a bit more now that a lot of ours are kind of home stricken. So thank you very much, and as always, what do Twitch people say? What do streamers say? In any case, I hope to see you more on some future AWS streams. I hope to be doing this relatively often and with some interesting topics to you. I think we'll continue on CDK and maybe CloudFormation in the coming days. I plan to do some more beginner-friendly sessions as well. Hope to see you soon. Bye-bye.